Hello everyone, welcome back to another video for the series. I'm Inoq and today I brought a IMO shortlist problem. It's an algebra problem and yes, so actually it's been a while since I read the solution for this problem and I'm making this video to check myself if I really understood the problem. So if I make mistake or if I cannot continue in the middle, please forgive me. I'll try my best. Professor Oak is feeding his 100 Pokemon. Each Pokemon has a ball whose capacity is a positive real number of kilograms. So we have 100 and each has a ball. Oops. And their capacity is a positive real number of kilograms. These capacities are known to Professor Ock. The total capacity of all balls is 100 kilograms. Okay, so these are all like positive, and when we add them, we get 100. Distributes, he has 100 kilograms of food, and it may be larger than the capacity of their ball. The dissatisfaction level of a Pokemon who receives n kilograms of food and whose ball has a capacity of c kilograms is equal to find the smallest real number d such that, regardless of the capacity of the balls, Professor Oak can distribute the food in a way that the sum of the dissatisfaction levels overall I'm sorry, all the 100 Pokemon is at most D. Yeah, I need to read that part again. Find the smallest real number D such that, regardless of the capacities of the balls, Professor Oak can distribute the food in a way that the sum of the dispersion level. Okay. So we want to find the maximum value of the minimum dissatisfaction levels. Great. I think I remember the solution. Like it started with, okay, so because Professor Ock knows the capacity of each, why don't we sorry, why don't we distribute the food in a way that everyone must have a remainder. So okay, so let's say everyone has a capacity of 1. That's our first case. C sub, I'll say I. Like the first one will be C sub 1, second one will be C sub 1, C sub 2, 3, and so on. C sub 97, 98, 99, and C sub 100 equals, like they're all equal to, let's say, 1. And Professor Ock is going to distribute the food in this manner. So it's going to distribute 0.5, 0.5, 0.5, and so on until, wait, how about I like this? So Professor Ock, sorry, I missed this condition. Professor Ock distributes 100 kilograms of food in a such way. See if a non-negative, okay, I'm sorry. Yes, n sub 1, n sub 2, n sub 3, 98, 99, 100. They're all integers, non-negative integers. It's just non-negative integers, like this, right? Yes. Okay. Then, sorry, this is our first scenario where C sub, I'll say 1 equals C sub 2 equals dot 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 equals C sub 99. So because we need to find the maximum of the minimum value, we need to like find our lower bound of D. So they're all equal to 0.5. Then obviously 100 should be 100 minus 0.5 times 99 equals 40, 49.5, right? Is it 49.5? I think so, because when we minus 0.5 minus, yes, that's right. So we have 50.5. I think this, yes, that is correct. And because the Professor Og knows the capacity, he's going to give okay, so he's going to give 50 kilogram to C sub. So equals 50. Now he has 50 kilograms left. Now he's going to give it's N, not C. I'll just rewrite that. 1 equals N sub 2 equals N sub 50 equals 1. And N sub 51 equals N sub 99 equals 0. Because it's non-negative, it can be 0. So does this add up to 100? And it does. Now what is our dissatisfaction level here? We have 0.5, 0.5 here, so 0.5 times how many? 50. Plus we also have 49 from here, 0.5 times 49, plus you have 0.5. This is equal to 0.5 times 100, which is 50. So from our first case, we know that D must be greater than or equal to 50, because that is our lower bound. Now let's consider the second case, where this time Professor Og decided to distribute in like a smart way. And that is giving the, okay, so we know that as C sub I is a real number, so it has an integer part and fraction part. But I really wanted to use N for integer parts, but that's quite unfortunate. Let's use alpha because we usually say N plus alpha, but we have N here, so which variable should we use? Integer. How about I because it's integer and F because fraction? We can rewrite C sub I like this. So and now what Professor Og is going to do is, because we know that C sub 1 through C sub 100 adds up to 100, we know that I sub 1 plus I sub 2 plus dot 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 plus I sub 100 is less than or equal to 100. Meaning, Professor Og can give integer, like, can give, wait, what's the word? What's the word? Like the food? Yes. Can give the food in a way that every Pokemon gets like the integer parts of their capacity. So then we will have, so Professor Og here. First one, our Pokemon 1, 2, 3. Our first one got, wait, so this guy has I sub 1 plus f of 1, I sub 2 plus f of 2, plus f of 3. Why am I keep saying 97? F of 98, f of 99, oh, 100 plus f of 100. Then, because the professor all gave the integer parts, we have f of 1, f of 2, f of 3. So these are the dissatisfaction level of the populants. So we're just thinking about different ideas on how we can distribute our food. Now, we know that when we add them, this is obviously an integer. Oh, I'll say a natural number. Could be 0. And the reason is because when we add all of this is 100, which is an integer, I sub 1, I sub 2, I sub 3, all the way up to I sub 100. They are integer, so if we subtract integer from integer, we have integer. So that's like the basic idea here. So Professor Ock has an integer amount of food left. Then, why don't we give the food starting from like the 100 document, like 1 kilogram each, to compensate the fractions. So it would be like, so the total dissatisfaction level here, like D, would be, I would say lowercase d because that's not the same D as we defined. That's defined by the problem. So this is equal to f of 1 plus f of 2 plus, let's say the remainder is R. So, oh, wait, what happened? Is 100 minus, yes, this sounds like a good definition. So we have D, dissatisfaction level, dissatisfaction level. Oh my goodness. Level equals f of 1 plus f of 2 plus dot 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 plus, let's start from here, 1 minus f of 100, f of 100 minus 1, that's yeah, what was our definition? I think yes, I don't think this is, or I can just write it in a way that follows the convention. F of, so this thing I saw, that was what is given by the problem. And then our last one will be I sub 100 plus like R minus, I think plus 1. And we need to carefully define it here because we don't know how many R we have, and I think we should be quite careful here on how to to approach it. Because this is assuming that r is not equal to 0 this time. Okay, then let's split it. This is equal to, let's split it. Then we know that until 100 minus r, we will not have so 100 minus r Pokemon will not get it because we're going from backwards, right? And there's a reason why we go backward, and I think, yes, I'll explain it as we proceed further. We have plus ice of 100 minus r plus 1, ice plus 1. So 100 minus r plus 1 minus plus dot 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 plus until we get I solve 100 minus r plus r, which is 100, minus r plus 1 minus f of 100. So let's simplify this. We have f of 1 plus f of 2 plus dot 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 plus. That's our first half, and the other half is plus 1 minus f of 100 minus r plus 1 plus 1 minus f of 100 minus r plus 2 plus dot 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 plus 1. I will just group them. Minus f of 100. And there is a fun trick that we can do. We know that this thing is equal to r. And notice that we define r like this. So rewriting this, we have 1 plus r minus so this is basically what we have right now. And we know that r equals this thing, and this thing is simply equal to f of I, which means we have f of 1 plus dot 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 plus f of 100 minus r plus f of 1 plus dot 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 plus f of 100 minus f of 100 minus r plus 1 plus. So these parts cancel. So we have is equal to 2 times f of 1 plus. Yes, and this is our dissatisfaction level until now. Yes. How should we continue from here? I actually, yes. So how should we continue? This is our dissatisfaction level. We actually, yes. We actually need to use average here. So let's say that without loss of generality is greater than or equal to, f of 100. Then we have the average of all these numbers So 100 minus r. This thing must be less than, oh, actually, I think I accidentally swapped them. Like this. Then we have this thing less than or equal to 100 over everything. And that is because, like, that's just the basic property of, like, arithmetic means. So, yes, so if we say that this is true, and this is totally fine because we're just rearranging the position of Pokemons, and that's totally fine. So if it works for one group of Pokemons, then if we permute them, there's nothing wrong with it. So from here, we know that this is true, and yes. So our dissatisfaction level is less than or equal to this number. And we know that this is equal to R over 100. Okay, because we know that this is true, we have 100 minus r less than or equal to r times 100 minus r. Yes, this, right? Because we can just multiply this. R is r must be less than 100 because the integer parts should exist and f of I are not equal to, so for r to equal 100, we must have f of I equals 1, but that doesn't make sense by our definition. And we can, from here, let's try and use something special here, because I think we're almost done. Like I remember this form of fraction, and I'm pretty sure, yes, I'm pretty sure we're almost done. So yes. Oh yeah, how should we, wait, please allow me a moment for me to think. We have for to screw itself. Oh, I see it. R times 100 minus R. Two times by AMGM. So we have 50. Yes. So we know that this is true by AMGM inequality. So we have this thing less than or equal to 200 over 100. Therefore, if we multiply 2, equals 25 times 2 equals 50. So we have D less than. So this is our upper bound of D because this is universally true. And we had another lower bound because we need to contain everything. We have this. Therefore, D is equal to 150. And the question, yes. Wow, 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 yes. This was quite a long solution. I cannot believe that, yes, I was able to continue. I think kick for this problem is like just like every problem, if we find something complex, then we start by like giving examples, listing examples, and trying simple stuffs. And I think that's our first condition. And I think the second one was quite interesting because this is a smart way of like counting. And from here, if we have thought of this one, I think it's quite obvious from here. Ah, yes, I forgot to explain why we did it backward. And the reason why we did it backward is because actually it doesn't really matter. It doesn't really matter actually. We just need to change like this, I think. Then we will not have any like problems, but maybe we could try. Wait, should we just do it right now to see? Yes, let's just do it right now. So if we do it from backwards, we have f of 1. I'll just because we know like the general idea, I will just write it. 1 plus f of 2 plus backwards. I forgot. 1 minus f of 1 plus 1 minus f of r plus f of r plus 1 plus this is equal to r minus f of 1 plus and the reason why I did it backwards here is because I remember the official solution doing it starting it from backwards. So that's why I did it. Then writing our average. But actually, I don't think it really matters. Oh, wait, something's wrong. Something is off. 100 minus r. Yes, of course. This thing is obviously less than or equal to 1 plus. So we have f of r plus 1. And we know this is less than or equal to 50 and 25. Therefore these. Actually. Oh, wait, we actually get the same answer. So it didn't really matter. So we could actually start like giving from the front, but yeah, why did the official solution start giving from backwards? From like the last Pokemon. We could just start giving from the first one, but I don't really get why, but anyways, I think it's the same process, so like trying to think of this idea uniformly was quite interesting. And I think this also somewhat contains the fundamental idea from function equations because we were thinking about d as like a universal like value, but we also think f of x as like the function if we are solving if problem related to function equation. I'm not sure what I'm saying, but like I think you get it. So yes. I think if we do it from here, it was pretty straightforward. Like here, this step was also, I think, quite self-evident. But here, like this AMGM is like crazy. How can we think of this AMGM like here, right now? This is amazing. And after that, we can just simply find it. So overall, I think I learned a lot from this problem. I really loved it, and I really enjoyed it. If you also like the problem, please don't forget to like and subscribe. And I'll come back tomorrow with another very fun and interesting problem. Thank you and see you tomorrow. Bye.